Okay, how ARC works differently on Objective-C and Swift. While both languages uses automatic reference count to manage memory without a garbage collector, underlying implementation and safety guarantees differ significantly. Okay, here are differences. Weak reference implementation, global versus local. Objective-C uses global site table. So basically it has only one site table and everything will be pushed into that. So when you create a weak reference in Objective-C, the runtime register in a global hash table. When the object is deallocated, the runtime must acquire a lock on this global table. Uh, Search for object address and nail out the weak pointers pointing to it. This can cause the thread contention. Okay, but in Swift, what happens is like the site table is created per object, and weak reference points directly to the site table. This is generally more efficient and reduce global locking contention. How the unowned references work is like in a Objective-C, there is like a dangling pointer. If the target object is deallocated, the pointer is left pointing at the garbage memory. Accessing it results in undefined behavior. In Swift, tracks the unowned count. If you access an unowned reference after the object has died, then the runtime detects the zombie state and triggers deterministic crash. Objective-C, the reference count is historically stored in a global hash table ostensibly in the object header. Okay, it generally tracks the single retained count. In every object in Swift, it has like a 64-bit inline ref count. It tracks three open separate counts, so strong, unknown, weak. In Objective-C, there is only one count, and Swift we have like a three. It supports site table mechanism natively to handle overflow and weak references. Objective-C, ARC only manages Objective-C objects. C constructs are not managed by ARC. You cannot easily put Objective-C object inside the C struct without complex bridging on safe pointers. ARC is integrated into entire type system in Swift. Objective-C heavily relies on the auto releases method, often return object that is valid for a while. In Swift, the Swift compiler is more aggressive about optimizing the life cycle. It prefer inserting explicit retain and release points rather than using the auto release.